Okay, this how-to video is going to describe the basic types of simulation available inside PSpice. We have an existing common emitter amplifier as the example design. This has been started as an empty analog or mixed AD project and drawn with parts from the PSpice libraries, including the sources. The first simulation that will be considered is the bias point. In this, the sources are connected and the circuit allowed to stabilize to get the bias point. To set this up, we're going to do a new simulation profile. Let's just give it a name of bias and say OK. Once the simulation settings come up, we get the options to pick the bias points from the analysis type. We'll leave the rest of the settings as they are and say OK, and then we'll run the simulation. Once the simulation is complete, the probe window comes up, but obviously there's no results in the probe window, so if we go back to the schematic, we can actually turn on the voltage, the current and the power markings respectively to see the results from the simulation. The next simulation we're going to consider, so let's just turn off these markers, will be a DC sweep. In this case, the DC voltage source for the circuit will be swept from 1 to 10 volts using a specified increment. The resulting circuit bias will be stored for each simulation. Since there are a number of results, these can be viewed in the probe window. So we'll go to and edit the simulation profile. So what we could do is we could create a new simulation profile if we wanted to. We could do that for any of these, but we're just going to edit that for speed in this example. And we're going to change the analysis type. We're going to set this as a DC sweep. Then we're going to specify the voltage source as V2. We're going to specify linear as sweep time with a start value as 1 and an end value of 10 and a 0.5 as the increment. Then we'll OK the simulation settings. Now this time we can actually add a voltage marker, so we can take a marker from either the multi-marker options here, or we can do it from the PSpice menu as well, and we will add this to the coal net. Once that's done, we'll run the simulation. Once that's complete, we'll actually see the result of the V-coal trace in the probe window. The next simulation we're going to look at is the AC sweep. In this case, the sources are applied, the circuit is allowed to stabilize, and then the AC source or sources are swept with the parameters specified, similar to a frequency generator being swept through a range of frequencies. Before running the simulation, we need to make a small change to the circuit. We need to add a bypass capacitor, which will be added to the junction between R4 and R5. So what we're going to do is we're just going to use P to place a part. We haven't got any libraries, so we're going to add a library, and the important thing to remember here is taking from the standard capture libraries. So towards capture library, we'll actually go to the PSpice libraries and we'll add the analog library, and then we'll add a capacitor. Let's just pop the capacitor in here. Let's just zoom in, and we will just wire the capacitor in. And we're also going to change the value of the capacitor, and we're just going to make this a 1U. And we'll edit the simulation profile. We'll change this to an AC sweep. We're going to set the AC sweep type to log and decade. The start value is going to be 10. The end value is going to be 100k. And the points decade we're going to specify as 11. We'll say OK to close the simulation settings, and we're going to run the simulation. And when we look at the probe results, the voltage marker remains from the previous simulation for an AC sweep. It might make a bit more sense to delete this marker, and what we'll do is add a different type of marker. So if we go back to the design, we'll delete the voltage marker, and this time we'll go to PSpice markers, the advanced options, and we'll add a dB magnitude of voltage to the coal net. Once the marker's there, we can then go to the simulation and actually see the results. The final simulation to be considered in this session is the transient analysis. The results of this simulation are similar to probing the circuit with an oscilloscope. So we'll go and edit the simulation profile again. We'll go to the Analysis tab and we'll specify this as a time domain transient. We'll set the runtime to 10M. This will give us 10 cycles of the 1K source in the output window. We'll say OK to close the simulation settings, and then since the voltage at the coal net is required, we'll delete the dB marker. And then we'll run the simulation. The results are okay, but the resulting sine wave is lacking in resolution because PSpice will try to minimize the number of evaluations of the design. This can be improved by changing the simulation profile. So we'll go back to the schematic, we'll edit the simulation profile. Now this time what we'll do is we'll set a maximum set size to 10U to force PSpice to re-evaluate the circuit more frequently. We'll say OK to the simulation settings, we'll rerun the simulation. Once that's done, we'll go to look at the simulation with the probe window, and you'll see that the quality of the resulting waveform is significantly improved. That ends this how-to video.